So this question was asked in GATE 2016 Electronics and Communication in paper set 1, in which you have given a signal x of n, which is represented by these impulse signals, and you have given that x of e j omega is the discrete time Fourier transform of x of n. Then you need to find out this integral value, that is represent from minus pi to pi x of e to the power j omega sin square 2 omega d omega. The NPTEL reference for this question is Principle of Signal and System by Professor Aditya K. Jagannatham, IIT Kanpur. You can find reference in the lecture, that is definition, inverse, DTFT, convergence, DTFT, and jet transform, DTFT. So this is a lecture name. So the useful data for this question is that the DTFT, discrete time Fourier transform expression, is given as x of e to the power j omega is equal to n equal to minus infinity to infinity x of n into e to the power minus j omega n. So if you have given a x of n, you can find discrete time Fourier transform, that is x of e to the power j omega, by this expression. Also, the inverse DTFT, that is if you have given x of e j omega and you need to find out x of n, that will be given by 1 over 2 pi. This integration limit will be in the 2 pi limit, x of e to the power j omega into e to the power j omega n d omega. Now this is your first equation and this is your second expression. Now in the second, if you put n equal to 0, then you will get x of 0 value, which is equal to 1 over 2 pi integration over 2 pi limit, and this is your x of e j omega, and when you put n equal to 0, this becomes 1, and this is similarly d omega. So x of 0 value can be find out by x of e j omega by integrating it over from minus pi to pi. Now coming to the solution, in this question you have given x of n, which is equal to 6 of delta n plus 2 plus 3 delta n plus 1 plus 8 times delta n plus 7 delta n minus 1 plus 4 delta n minus 2. So in the sequence form, it can be written as x of n equal to 6, 3, 8, 7, 4, and the n equal to 0 is this one, this point, that is 8. X of n equal to 8 is the n equal to 0, and this is n equal to minus 2, and this is n equal to plus 2. Now this is your x of n is given, and you need to find out 1 over pi integration from minus pi to pi x of e to the power j omega sin square 2 omega d omega. You need to find out this value. Now sin square 2 omega can be given by 1 minus cos of 4 omega upon 2. So by putting this sin square 2 omega expression, this expression becomes 1 over pi minus pi to pi x of e to the power j omega into 1 minus cos 4 omega upon 2 d omega, or you can write this one as 1 over 2 pi minus pi to pi x of e to the power j omega d omega 1 over 2 pi minus pi to pi x of e j omega into cos of 4 omega d omega. Now you divide this integral in two parts. One is your 1 by 2 pi minus pi to pi x of e j omega d omega, and the second one is 1 over 2 pi integration of minus pi to pi x of e j omega cos 4 omega d omega. So let's assume this one as I1 and this one as I2. So now your I1 is 1 over 2 pi minus pi to pi x of e to the power j omega d omega. Now from the definition of discrete time Fourier transform, your x of n is given by 1 over 2 pi and integration over 2 pi and x of e j omega into e to the power j omega n d omega. So when you put n equal to 0, you will get x of 0 equal to 1 over 2 pi integration over 2 pi, and this becomes similarly x of e j omega d omega. So this integral value is nothing but the value of x of 0. So the value of x of 0 is given by 8. So your I1 becomes 8. Now coming to I2, your I2 value is given as 1 over 2 pi minus pi to pi x of e to the power j omega cos of 4 omega d omega. Or you can write this one as 1 over 2 pi minus pi to pi x of e to the power j omega into e to the power j 4 omega plus e to the power minus j 4 omega upon 2 d omega. I am writing cos of 4 omega as e to the power j 4 omega plus e to the power minus j 4 omega upon 2. Further, I can simplify this equation as 1 over 2 pi 1 by 2 pi integration from minus pi to pi x of e j omega into e to the power j 4 omega d omega plus 1 over 2 pi integral minus pi to pi x of e j omega into e to the power minus j 4 omega d omega. So when you see this expression, this is nothing but when n equal to 4 in x of n expression, and this is when n equal to minus 4 in x of n, but your x of n is lying from minus 2 to plus 2 only. So these values, that n equal to 4, x of n is 0, and for n equal to minus 4 also x of n is 0, because x of n is lying from minus 2 to plus 2. So this whole I2 becomes 0, and your answer for question will be given by only I1, that is equal to 8. So the correct answer for this question is 8.